Hi everyone. In this video, I will be demonstrating my 8086 assembly language program that computes the sum of all numbers from 1 to n, where n is a number entered by the user, and I will walk you through how the program works, the algorithm I use, and the challenges I face while building it. Now, let's get started. Here's the program running. When I launch it, it displays a title, the title sum of 1 to n program, and then asks me the number from 1 to 9. So let me just type 5. So the program immediately prints the result 15 because 1 plus 2 plus 3 plus 4 plus 5 is equals to 15. Now let me try entering another number. So let me just accept that. And let's try the number 9. And it's give us 45. And if I enter something invalid, like the letter A, it shows invalid input. Simple, clean, and it works entirely in 8086 assembly language. Now, how the program works. Now let me explain how it works under the hood. The program is divided into 3 segments. The stack segment, where it reserves 256 words or 512 bytes for the stack. And the data segment, where all the variables are stored in, and the code segment, where the program lives. So the data segment in this area here, it stores all of our text, the title, the prompt, and the error message in the result label. It also stores the variable called the sum value to hold the final answer. In the code segment, the program follows these steps. As can you see here? First step is the setup. It loads the data segment address into the DS. So we load the data segment address into the DS register, so the program can access our stored messages and variables. Step 2, print title. It displays the title and prompt. We use the DOS interrupt 21 hex with the function of 09 hex to print our strings to screen. Now step 3 is read one key from keyboard. So read the input. We use the function 01 hex to read a single key press from the keyboard. The character comes back in the AL register as an ASCII value too. So step 4, validate the input. We compare AL against the ASCII codes for 1 and 9. If the input is below 1 or above 9, we jump to the invalid section and prints the error message. Now next is the convert ASCII to a real number. So we subtract ASCII 0, which is 48, from the AL. So if the user press 5, AL becomes 5. Now let's talk about the algorithm. The algorithm is just a straightforward iterative summation, but in high-level pseudocode, it looks like this. In assembly, we don't have a built-in loop structure, so we manually handle it using CMP to compare the GE, to jump when equal, and INC to increment, and GMP just to go back to the top of the loop or just repeats the loop. So in the same logic, just read in a hardware level. Now let me talk about the challenges I faced while making this program. My biggest challenge was just simply writing the code itself because I'm not used to assembly language. Coming from higher level programming, assembly thinks completely different. You have to manually control every register, every step, and every small details, and there's no shortcut. For example, something as simple as printing a number, it took multiple steps. Dividing it, converting each digit to ASCII, saving register values carefully, and printing them one by one. In other languages, that would just be one line. But by breaking the program down step by step and carefully studying each instruction, I was eventually able to get it working correctly. And that's the complete program. To summarize, it reads a number from 1 to 9, validates it, computes the sum using a loop, and displays the result. All written in 8086 assembly language. So, thanks for watching.